Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Haiqal Brinald and I am presenting my group to present our task about implementation of predictive maintenance strategies in oil analysis industries. And our instructor is T.S. Ahmad Nizam bin Jamaluddin. Without wasting any time, let's move to introduction.
Oil analysis is a routine activity for analyzing oil health, oil contamination and machine wear. The purpose of an oil analysis program is to verify that a lubricated machine is operating according to expectations. When an abnormal condition or parameter is identified through oil analysis, immediate actions can be taken to correct the root cause or to mitigate a developing failure. An oil analysis program begins with an understanding of machinery reliability and a willingness to improve on the current reliability status within the plant. Oil analysis is a tool which can be used to help monitor oil lubricated equipment. It's like taking a human blood sample. It doesn't provide all of the information regarding what is happening within the equipment, but it can provide valuable insight. The objective of predictive maintenance in oil analysis are first, to understand the condition of the oil and improvement by using modern real-time data collections and analysis system. Second, to learn wear preventive properties of different types of lubricant. Third, to understand the relationship between the test load and the wear rate.
Salam sejahtera. Today, I will present about what is predictive maintenance and why do we implement predictive maintenance. First, what is predictive maintenance? Predictive maintenance is where we use condition monitoring tools and techniques to track the performance of equipment to identify defects and help fix before failure. Next, predictive maintenance takes all information into account such as past, present and future and offer an ideal time for maintenance before any failure. And last is predictive maintenance is where the machinery conditions are periodically monitored and this enables the maintenance crew to take timely action such as machine adjustment, repair and overhaul. Second part is why we implement predictive maintenance. As in general, when predictive maintenance is used correctly as a maintenance strategy, maintenance on machinery is only conducted when it is necessary. This brings several cost savings. Next is predictive maintenance allows for safety compliance and increased asset life. Knowing what failure is likely to occur when the maintenance schedule, adjustment and repairs can be performed before the asset fails. The benefit we implement predictive maintenance is it will minimizing the time the equipment is being maintained, minimizing the production hours lost to maintenance. Next is minimizing the cost of spare part and supply. And last benefit is increased equipment lifespan. Next is why do we implement oil analysis as in predictive maintenance. Oil analysis is a set of monitoring and inspection steps and process that provide insight into the condition and state of machinery lubricating oil. Predictive maintenance approach based on oil analysis can include a wide range of topics and tactics such as visual inspection for contamination and viscosity, fluid property inspection for contamination and viscosity, continuously oil monitoring, and wear analysis. As for the benefits, early detection of unexpected equipment wear indicating the presence of potential issues in equipment functionality. Next is an accurate picture of when oil should be replaced. so that oil does not remain in service once no longer effective. Last is a frontline look into equipment performance, since all conditions are closely related to equipment efficiency, wear and effectiveness.
Hello, my name is Anis Nafal. So right now, I would like to present about the workflow of this testing study of oil analysis. So the first step is collecting. Collecting the oil sample for the oil components having that tested usually in commercial laboratory. And the second step is testing. Matching testing oil types and likely failure modes, and matching flagging to corrective response plan. One size fits all approach or application specific. So to this question, we also want to consider whether to perform a single test package for all the asset, or whether some of more critical application required additional testing. And the other thing we need to consider is routine or trigger tests. We should consider what type of testing should be performed on routine daily basis, and which should we be performed on an exception basis or trigger basis. The third step is interpreting. So by interpreting, we have to consider the identification of actionable work, component wear. By component wear, I mean some component wear is to be expected, and wear rate may increase with age. Filtration may give the impression of steady state wear. Abnormal wear can usually be explained by, like, the first one is like the first thing to consider is harsh operation. Second, ineffective maintenance. Third, poor oil condition. Fourth, excessive contamination. Fifth, mechanical issue. And the other thing is oil condition. So the goal for the oil condition is for monitoring oil condition. First, confirm the correct oil is being used, and second, identify when oil should be changed. Third is maintain oil condition for as long as possible or as long as needed. Contamination. Oil contamination can be many things: external ingression, cross contamination, oil breakdown, and then contamination control is important. So we have to consider the hydraulic oil. 80% of all failure causes by contamination. And second is engine oil. Uh, Fuel dilution can lead to failures. And the last is turbine oil. Varnish can lead to unplanned downtime. So right here, how much contamination is too much? And define threshold. Second is increase from trend. And the last step is completing. So as we all know, is completing that work to restore the condition of the unit. Thank you.
Okay, now let's move to inspection methodology of oil analysis for predictive maintenance. First, we can visual oil checks for contaminants and viscosity. This method can be used once a day to be more effective, but if we use this method once per month is enough. Okay, this method can indicate the presence of debris, big pollutants, viscosity anomalies, and other concern that, if anywhere or defect detected early, can be easily remedied or corrected. This method also can reveal some serious issue with equipment wear, such as leaking. Okay, now second one is fluid property inspection for contaminant and viscosity. Okay, this method is more advanced chemical lubricating or study, which can provide even more data about the quality of oil, identifying the presence of tiny impurities and chemical signatures. This method indicate whether the oil is being worn. For example, our engine oil. Okay, this method should be done frequently enough to uncover possible problem before they become a major problem on our engine or any equipment. Okay, the third one is continuously monitoring oil conditions. Since oil analysis technology and combine it with manufacturing technologies, we can have a network sensor and data analytics, which provide us a new step for this important process. This equipment sensor enable a more educated and data-driven approach. For example here, we have this TPC sensor. TPC sensor is used in vehicle, which it job to control the usage of oil, petrol or diesel. And this sensor also can give us indication if an engine having a problem. For example, if a car having a oil control problem or any other problem relating to oil, um, this sensor will send a data to ECU, and from the ECU of a vehicle, we can identify what is the actual problem related to oil. Okay, in brief, this sensor or any other sensor such as map sensor in the car also can give us indication for the problem that the vehicle have facing it, and the data is the real-time data. Okay, now is the last methodology, which is wear analysis. Since oil comes into close touch with moving part, it will contain any debris, no matter how small it is. It will add up as parts wear down. The presence of debris will indicate the rate of equipment wear. Then we as a consumer, we can alert the maintenance professionals and operator to premature wear issues that suggest anomalous operation, which can be corrected early before it becomes the major problem. Okay, for the combination of the four previous method that I have mentioned, there is one method that is used nowadays, that combine the most modern technology nowadays, which is for ball tester. This test is run to measure the performance of lubricant with respect to wear. Okay, the methodology of this test is by placing the three fixed ball below here, and the up here we put another one ball that is rotated against the rest of the ball at the bottom of it. Okay, then the load is applied with fixed conditions such as load, temperature and speed. Okay, then the wear scar measurement can be performed by using the optical profilometry here in picture here. This is the machine used to measure the wear scar, and from this machine also can be used to judge the performance of lubricant with respect to wear. Okay, in this test, the international standard used is ASTM D4172 to measure the wear scar diameter of the ball bearing as well as the coefficient of the lubricant. In this test, the load is set to 392 plus minus 2 Newton, while the temperature is set at 75 plus minus 2 degrees Celsius. In this test, the result shows the smaller wear scar, meaning that the lubricant is better at preventing wear. Okay, the wear scar is measured on the three stationary ball here in the bottom, and the average is reported. Also, the coefficient of friction is measured. Okay, basically from this test is a new technology test, modern technology test run to know how the performance of the lubricant at preventing wear. Okay.
Assalamualaikum. My name is Muhammad Afiq bin Azman, and today I will talk about the application and the result from the experiment. The 4-ball tester method has been used widely in some industries such as automotive and machinery. In automotive industry, 4-ball tester has been used to analyze the engine oil whether it's suitable in lubricating the engine compartment. If the wrong viscosity of oil was used, it will reduce the engine performance and its lifespan also shorten. Various engine type produce various amount of torque, so it is very important to find the most suitable engine oil for it. In machinery industry, there are also specific industry that use lubricating machine in their production, such as textile, glass and paper industry. Textile industry machines use high-speed roller and components that are mobilized through bearings and other parts, so the significance and use of lubricants is increased to a very high level. The quality of textile produce affected by the smooth running of the bearings. For glass industry, the quality of lubricants will affect the size of production produced. The output is likely to be larger than expected because there will be no downtime. Lastly, paper industry machine runs on lubricants to support heavy rotating machine, so the output needs to be accurate in production at a faster pace. An experiment has been set up using 4-ball tester machine and 4 types of oil has been used, which are gear oil, motorcycle engine oil, canola oil and brake fluid to examine the wear produced by them, and this is the first data for gear oil. And this is the second data, which is for the motorcycle engine oil. It shows the coefficient of friction and the diagram of wear. And this is the third data for canola oil that shows its wear and coefficient of friction diagram. And this is the fourth data for brake fluid and its wear and coefficient of friction diagram. The result has been recorded and tabulated in the table. The table shows that the gear oil produced the least number to create wear and the brake fluid produced the highest number to create wear. It can be seen on its average area, radius and perimeter. The smaller the number, the least wear produced. So, the least wear produced in lubricant is suitable for high performance and high durable purpose.
Okay, right now I would like to explain about the barrier for to run the oil analysis in industry. So the first one is a poor control of sampling methodology. Second is analysis may have limited ability to interpret skills. Cost of additional in-house operations. Next is budget usage may not allow purchase of most efficient and precise testing equipment. Then to allow for on-site testing which limits sample handling and avoid need for capital expenditure. The next is additional infrastructure needed to support large amounts of data and additional maintenance needed for monitoring the technology itself. Next, quicker result mean quicker response times when needed. And the last one is as with our any new technology, its success depends on the user's ability to understand it.
For the conclusion, at the end of this study, we understand the use of an oil analysis in predictive maintenance. It is used as a tool for predictive maintenance. Oil analysis is one of the simplest ways to monitor contamination proactively. When implemented effectively, an oil analysis program reduces uncertainty, risk, and reactive works for a maintenance department. In addition, oil analysis can provide a detailed view of what is happening inside machine components. This is where the method of 4-ball tester being conducted so that we know whether the right oil is used or wrong oil is added. Besides that, oil analysis will reduce Oil analysis could save time and cost, where it will reduce the occurrence of major maintenance events that could be avoided by doing early detection, and reduce maintenance costs through a more proactive, predictive strategy informed by oil analysis. This slide shows all the reference of our studies regarding an oil analysis as a strategy maintenance and predictive maintenance. That's all from our groups. Thank you.